Hello friends of data streaming and stream processing, Gunnar here, and I'm back with another episode of Data Streaming Quick Tips. And today I would like to explore how we can use Flink SQL for aggregating the elements of an array. The use case is centered around processing change streams which we retrieve from a relational database. And in our case, they are forming a one-to-n relationship, and we would like to take the results of such a one-to-n join and emit them as a single document into a document store such as Elasticsearch. Let's do this. So let's take a look at an example. It's from an e-commerce application, and we are modeling the purchase orders placed by our customers. There are two tables. The first one, purchase orders, contains one header entry for each order. The other table, order lines, contains one entry for each order line of a purchase order, which means that there is a one-to-n relationship between the two tables. Now, let's assume we would like to implement a full-text search feature for orders and their lines, using Elasticsearch as a search engine. For this to work, we must compute the join between order headers and line items and push one document for each purchase order to Elasticsearch, including all the corresponding line items. This means we need to create a nested data structure with an embedded array containing the order lines, as you can see it here on the right-hand side. So let's take a look at the data in our database. And for that, I'm going to run a simple join, taking the purchase orders and the order lines table, joining them on the order ID, and then I will get this nice tabular result structure. Let's see how we can take and ingest the same data into Flink. So for that, we create two tables. First of all, the purchase orders table. Its schema represents the schema of the table above. And in the details, we say it's a Postgres CDC based table. We specify the coordinates of the database. And we specify it's about the purchase orders table. Let's do the same for the order lines table. So we now have those two tables, and just as in the relational database, we can join them together. So we can literally take the select statement from above without the order part and run this within Flink. And now this will be incrementally recalculated. So if we do some data changes, let me go and update one of the purchase order entries. Then this result, this query below will be recomputed, and we will see that the purchaser ID of those two affected lines got updated. And again, if I change it back to 1001, we will see the results are recomputed. The problem now is this sort of rectangular result structure isn't well suited for ingesting this data into a document store such as Elasticsearch. Right now we have one row in our result set for each order line, whereas we actually would like to have one object structure for an entire purchase order. So we somehow need to take all the order lines of an order and aggregate them into a single record. So let's see how we can go about solving this issue. So let me cancel this query and let me create a new table, which for now contains a lines string attribute, which will contain all the lines of one purchase order. And in order to merge all the order lines of one order into the string, I'm going to use this JSON array egg function, which comes with Flink SQL. So this takes an array of data and emits a string which contains a JSON array. And this table is backed by Kafka topic. In my case, I'm running Red Panda, so I can take a look at the data later on. Now, in order to populate this data, this table, I'm going to run this insert query. So here I'm selecting all my purchase orders, and then for each purchase order, I run this correlated subquery where I take the data of one order line, which I convert into a JSON object, and then I invoke this JSON array egg function to take all the order lines from one order and emit this JSON array as a string attribute. And as this table is backed by our Kafka or by our Red Panda topic, I can take a look now by using the RPK command coming with Red Panda, and I can examine the events which are coming into this topic. And here I see now, okay, my lines, they are this stringified JSON attribute. So not quite ideal yet, but we are getting there. And now as I'm doing updates, I see that those updates are also propagated to this topic. And for instance, now if I'm going to change the quantity of one order line, I also see that this lines string of the corresponding purchase order record in this topic gets updated accordingly. Now at this point, we have solved the first half of our challenge. We have aggregated all the data per purchase order and its lines into a single object structure. with the lines being emitted into this lines string as our JSON array. Now, this stringified JSON representation isn't ideal yet, right? It's not type safe, and it won't be easily ingested into Elasticsearch. So let's see what we can do about this. And for this, I'm going to stop this existing job, and I'm also dropping our order with lines table. So now I'm going to recreate this table, but this time I'm using a typed structure for my order lines. So now this actually is an array of rows, and each row has the schema which describes one order line. And now, of course, the question is how I can actually populate this array of rows of order lines, because there's no function in Flink SQL which would help me with this. And for this purpose, I've implemented a UDF, a user-defined function, which essentially keeps track of the objects which are assembled into an array and then emits the objects as an array. And I'm going to do a separate video about UDFs, about custom aggregate functions, so I'm not going to dive too much into the details yet, but just keep in mind this essentially assembles all the lines of our purchase orders. Now, in order to use this function, I've already added this to my Flink task manager and job manager applications, and I need to register this function. So I'm calling create function with the fully qualified name of the function, and now I can make use of this. So I can run my insert query again, and now I'm using this array aggregation function, which I built myself, and now this will collect all the rows of each purchase order. And now if I look at my topic data in Red Panda, I see now my lines are no longer a single string, but they are essentially an array of those order line structures. And if I modify my order lines, if I change the quantity, again, I also see how this update gets reflected in a properly, strongly typed way. Before finally taking this data and ingesting it into Elasticsearch, there is one specific feature which I would like to discuss, and this is how often this aggregation actually gets computed and the corresponding events get emitted to our topic in Red Panda for now. So for this purpose, I'm going to insert a new purchase order, which has 3 order lines, and we can then take a look at the events on the topic to see how often the results are emitted here. And now what we see is for those 3 lines, well, this aggregation got run 3 times. So first I see my purchase order with 1 line, then with 2 lines, and finally with all 3 lines. And now, of course, emitting all those intermediary events isn't ideal. It would, for instance, produce lots of load on our Elasticsearch cluster for no good reason. And there's one feature in Flink SQL which can help us with this, and this is called mini batching. So let me stop this job, let me enable the mini batching, and now this gives us some control for how long and for how many events we would like to buffer before we emit such an aggregation. So let me recreate this query, and now if I'm going to persist another set of line items for the same order, then I'm going to see here, okay, there's only now a single update event which got emitted, which now contains the first 3 and then the second set of 3 events instead of emitting all those intermediate events. And of course, that's much more efficient. Okay, let's finally ingest the data into Elasticsearch. And to make things a bit more interesting, I'm actually going to also join our order data with customers, with the customers' data, and for the sake of the example, also their phone number data. So I'm going to create 2 more tables, the customers table and the customer phone numbers table, so we can ingest also the changes to those 2 tables into Flink. Then I need to recreate my target table. And as you see here now, I actually have 2 arrays. So I have my order lines array and I have my phone numbers array within a substructure for the purchases or the customer's information. I'm going to issue my insert query, and here I'm using the array aggregation function also 2 times. So once for aggregating the data from the order lines and another time for aggregating the phone numbers data. And now we can take a look into the data in Elasticsearch. So I'm using HTTP to invoke the REST API from Elasticsearch. And here I see now the order data with the purchasers information, their phone numbers, and the order lines. So let's see whether it works. I'm going to insert another phone number record. And if I invoke the REST API again, I just fetch this particular order entry, then I see, okay, also this phone number got added. And just to wrap things up, of course, also deletions work. So if I'm going to delete all the lines for one particular purchase order, this will then be propagated to Elasticsearch. And if I retrieve the purchase order from there again, well, now then I will see that there is actually no more lines in this order. And this is how you aggregate the contents of an array using Flink SQL. Either using the built-in function JSON array or using a custom UDF if you want to emit a type-safe representation of this data. So we can materialize the results of a one-to-n join and propagate those results into a single document in a store such as Elasticsearch. If you want to play around with this all by yourself, you can find the link to the decodable examples repository in the links below. And also in the coming weeks, I'm going to produce another video where I will show you how you can take such a custom UDF and deploy it as a custom pipeline onto the decodable platform, just in case you don't want to run the Flink infrastructure for all this by yourself. Until then, happy streaming!